Hey guys, we're going to talk through simplifying numerical expressions and how we can really use the understanding of what the operations tell us in order to simplify that expression. Our content objective for this unit is I can change math expressions into phrases and phrases into expressions by focusing on the meaning of the operation. I can explain why an expression matches a phrase or why the phrase matches an expression while playing memory. So there's a fun game that the kids are going to get to participate in during this unit. The first thing I want you to do is just take a look at these expressions and think about something that you notice. We hope here that the kids just kind of think about the operation. I see some addition, there's multiplication, subtraction, division, and they all have 5 and 4 as their digits, but we wonder if their values are different. I wonder why maybe a kid may point out that 5 divided by 4 is an improper fraction, all of those types of things. So what I would at this point is say, which one of these is representing 4 increased by 5. 4 increased by 5. 4 increased by 5 is 4 plus 5. Why is it not 4 times 5? So we have that conversation about what the multiplication means and it being 4 groups of 5, not having 4 and increasing it by 5 more, having $4 and getting 5 more. The multiplication means you have 4 groups of 5 things. Or the subtraction means something different. We're not increasing when we subtract. The division we know has a value of less than 1, so it's definitely not increasing. And then 4 plus 5 is having 4 things. Having 5 things and increasing it by 4. And the difference between those two phrases. So the increase is the same, but it's what we started with and how much we're increasing it. Have that conversation with your kids to get them really thinking about what those operations mean. So here's another situation. The quotient of 36 divided by 4 is 36 divided by 4. Well, why isn't it these other situations? Why isn't it any of these other expressions? And have that conversation again about what really is subtraction. How is it different than a quotient or division? The addition, how is it different? What is happening with the numbers that symbol means that those numbers should be happening to those numbers? What does that symbol tell us? Here's another situation. 9 less than 23. 9 less than 23. Here's one of the harder ones because the numbers don't come out in the same order. 9 less than 23 is I have 23 and I have 9 less. But we write it as 9 less than 23. Let the kids have a conversation. We want them to really start thinking about what that symbol is telling us and how it affects the numbers. 8 times as much as 13. 8 times as much as 13. So we know we're not subtracting because that would mean we would be taking away or finding the distance between. It's not division because we're not splitting that 13 up. And again, here hopefully our kids would see that this value is less than a whole. So we have 8 times 13, and that symbol means we're going to have multiple groups, 8 of them, of 13. So, how does this help us when we're following the order of operations or we're simplifying an expression? For a simple example, 2 combined 5 or 2 increased by 5 or 2 plus 5, putting 5 and 2 together is a way of simplifying something 7 that has a value of 7. But what if the expression is a little more involved and has multiple operations? We still want the kids to think about what those operations are. So how could we read this? This means we're going to have 2 times double we're going to have two groups of 2 combined 5. So we're going to combine 2 and 5, and then we're going to have 2 groups of that. So that's one way the kids can see that we're going to definitely do that grouping first. So we're going to have 2 groups of 2 and 5 together. So if we simplify the 2 and 5 first, 2 plus 5, then we would find our 2 groups of 7, which equals 14. Let's extend it a little bit more. So here I have 2 groups, or 2 times 2 plus 5, 2 combined 5, 2 and 5 more, and then I'm going to remove 4. So thinking about that, I'm going to have 2 groups of this 2 plus 5, or 2 combined 5, then I'm going to remove 4. Okay, so let's simplify. That would make 2 groups of 7, take away 4. So I can't take away 4 from the 7 until because that's not a 7. That's representing 2 groups of 7, which is 14, and then I can remove the 4. So really having a moment to think about what the operation tells us and how that affects the numbers helps us start to develop an understanding of the order that the operations have to be performed in because of their hierarchy. Let's look at some other situations. What if I have 36 split into 6 groups? Okay, we know that that means there's going to be 6 in each group. So 36 split up by 6. We have 6 groups, or we all have 6 in each group. Okay, let's extend it. 36 split up into 6 groups, and I'm going to have 2 of those. 2 times 36 split into 6 groups. Okay, we'd have to find the value of us splitting it up first, and then we can have 2 of them. Let's extend it one more time. So this is saying that I have 20, and I need to remove 36 split up into 6 groups doubled. So think about that for a minute. I'm going to have 20, and then I need to remove 36 split up into 6 doubled times 2, twice as many. So in order for us to do the order that is appropriate to solve this, we're going to have to find out what the value of 36 split into 6 groups is. So let's read this phrase. 20 remove 6 groups of 2. So it's not a 6. That's describing how many groups of 2 I'm going to have. So that that moment they realize they have to figure out how many groups of 6 groups of 2 are, which is 12. And then you can have your 20 and remove it. This is one of the most common mistakes with our kiddos is they think they just work left to right. But if they pause and really think about the impact of what that operation is saying is happening with the numbers, it allows them to realize the order.